Now this question is given in GATE 2016. Let me read it out for you. A file system uses an in-memory cache to cache the disk blocks. So they are saying that there is a cache and there is a disk, right? The miss rate of the cache is shown in the figure. So here they have given us the what is the miss rate. The latency to read a block from the cache is 1 millisecond, and to read a block from the disk is 10 milliseconds, which means if the block is directly present in the cache, to read it the time taken is 1 millisecond. If it is not present in the cache, we might have to read it from the disk. In that case, the time taken will be 10 milliseconds. Okay, assume that the cost of checking whether a block exists in the cache is negligible. So just assume that we don't have any cost whether to check whether it is present in the hard disk or not. Sometimes what happens is, see, when you have various levels of memory, then we'll check whether it is present in the fastest memory or not. If it is not present in the fastest memory, we go to the second slowest memory, like that. In that case, what happens is second fastest memory. In that case, what happens? Okay, I'll just show you with the diagram. What I mean to say is, if you have CPU, and now if you have the fastest memory here, memory module, and then second fastest memory module here, M1, M2, and then third fastest memory module here, then what happens is CPU will check here. If it is not present here, then it might go here, right? Then in that case, there might be some time associated for checking here, right? So they are saying that don't consider that time. Okay, and now available cache sizes are in multiples of 10 MB, and they have given this diagram. Now this diagram is showing what would be the miss rate if you have blocks of cache size of this one. If I have cache size of 100 MB, which means this available cache sizes are in multiples of 10 MB. So which means 10 into 10. If your cache size is available cache size or the multiples of 10 MB means this is 10 MB. So if the cache size is 10 MB, then the hit rate is, or the miss rate is 80. That is what is given. If the cache is 10 MB, then the miss is 80. If the cache size is 20 MB, then the miss is 60. If the cache size is 30 MB, then the miss is 40. Miss rate is 40. If the cache size is 40 MB, the miss is I think it is 35, like that. So what is happening here is, whenever you increase the cache size, the miss rate is decreasing, isn't it? So why is this happening? The reason is, when the size of the cache is big, then there is a chance that you might find the required data available in the cache in most of the times. If the size of the cache is small, then you will not have the space to fill it with more data. Then most of the times you might not find the data you are looking for. That is why, as you increase the cache size, the miss rate is going to decrease. Now the question is, the smallest cache size required to ensure an average read latency less than 6 milliseconds is dash MB. So if the average read latency has to be less than 6 milliseconds, then what is the cache size that you want? So in order to find it out, we have to find out if our average latency has to be less than 6 milliseconds, then what should be the miss rate? Then from the miss rate, you can find out the cache size. That is how you should solve it. Okay. Now they are saying that the average read latency has to be less than 6. Okay, so I can write it this way. Now read latency has to be less than 6 milliseconds, and as you know, the read latency is going to be time taken to read from the cache whenever there is a hit in the cache, which means whenever there is a hit in the cache, then time taken will be time taken to read from the cache, h1 into t1. If there is a miss in the cache, which means 1 minus h1, then we should read it from the hard disk. This one should be less than 6 milliseconds, right? Now h1, and this one is given as 1 millisecond, plus 1 minus h1, and this one is given as 10 milliseconds, should be less than 6. I'm just cancelling out milliseconds. Okay, and now what do you get? minus 9 h1 plus 1 is less than, isn't it? 1 second. So it is h1 minus 10 h1, so it is going to be minus 9 h1 plus 10 is less than 6. That implies minus 9 h1 is less than minus 4. That implies 9 h1 is greater than 4. That implies h1 is greater than, if you see 4 by 9, this is going to be 0.433, something like this. Okay, so what does it mean? Your hit rate has to be greater than 0.433, something like this. Now if I have to find out the miss rate, it is nothing but 1 minus h1, right? So for that reason I'll multiply this one with minus on both the sides, then I get minus h1 is less than 0.433 minus 0.433, and if I add 1 on both the sides, then I get 1 minus h1 is less than 1 minus 0.433, so which is nothing but 0.57. so this is the miss rate is less than 0.57. so miss rate has to be less than 0.57. Got it? So if miss rate has to be less than 0.57, then it has to fall below this, right? So 0.57 is somewhere here, it has to fall below this. But then for 50 we don't know what is the block size required, therefore the next one is 40 is there. So if you go to the 40 and find out the block size, it is 30 MB. Got it? So what can we understand from this? So at least you should have a memory size or the cache size of 30 MB, so that you will have a hit rate of a miss rate of 40. When you have miss rate of 40, then the hit rate will be 60. When you have hit rate 60, which is greater than 0.43, the average latency will be less than 6 milliseconds. Got it? Okay.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkey's ranking is 400. If you are happy to get into IIT Roorkey, then getting into universities better than IIT Roorkey is easier compared to getting into IIT Roorkey. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is, we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.